Welcome to Solving One-Step Equations with Multiplication. I'm your host today, Mr. Pi, the math guy. And you have to remember, our goal when we're solving equations is to isolate the variable, meaning to get the variable by itself on either the left or the right of the equation. Speaking of the left and right of the equation, you'll often hear me say, when I'm modeling how to do problems, left, right, middle of an equation. That's because when we're solving equations, we have to balance the equation. Whatever we do to one side, we have to do to the other sides. That's done with the properties of equality that we're going to be talking about here in a little bit. For this example, all I want you to understand is that the equal sign is the middle of the equation. And on the left-hand side, we have x divided by 3. Notice how I said that, but we'll get to that a little later. X divided by 3 is on the left-hand side of the equation. And on the right-hand side of the equation, we have negative 8. So as we move forward, you're going to see, because of the properties of equality we're going to talk about, whatever we do to the left of an equation, we have to do to the right to find our solution. Solving one-step equations. When we're doing that, a property of equality that we're going to use, in addition to the addition and subtraction property of equalities that you should have already learned about if you're watching this video lesson, the multiplication property of equality reads, for all real numbers a, b, and c, if a is equal to b, then a times c is equal to b times c. What this property tells us is if we start with something such as a is equal to b, to maintain that equality we have to multiply both sides by the same thing. In this very algebraic property, that thing is c. In this numerical example I have here, 15 divided by 3 is equal to 5. That's a known multiplication fact. But we can change it and make it look the same on each side by multiplying each side by 3. In essence, we're multiplying by what's in the denominator. And when we do that, the 3's on the left divide out. In essence, they become 1 because 3 divided by 3 is 1, and 3 divided by 3, dividing out their greatest common factor, leaves us 1. The only number left is 15. So on the left-hand side, we have 15. 5 times 3 is a known multiplication factor, is 15. And there's the multiplication property at work in a numerical example. You should see how we can apply this property to equations that involve variables. Solving one-step equations with multiplication. In these problems 4, 5, and 6, what we're going to do is use the multiplication property of equality, which states that we have to multiply both sides of the equation to maintain equality. So in this problem, if we read it, x divided by 7 is equal to negative 4. Since x, the variable that's on the left-hand side of the equation, is being divided by 7, we perform the inverse of divide by 7, which is multiply by 7. Using the multiplication property of equality, we do it to both sides. On the left-hand side, if you imagine this as 7 over 1, the 7's can cross-cancel, dividing each of those 7's by a factor of 7. In essence, they divide out, but we're dividing it by 7, so we get 1 times x to give us x on the left-hand side, and we have achieved our goal of isolating the variable. We have 1x on the left-hand side of the equal sign. There's our equal sign, and on the right-hand side, we have to do negative 4 times 7, and that's a negative 28. 4 times 7 is a basic multiplication fact, and a negative times a positive is always a negative. If you want to, you can check your work here. We would check that work by substituting the solution, negative 28, into the original equation. Negative 28 divided by 7 is equal to negative 4. And in fact, that is true. 28 divided by 7 is 4. A negative divided by a positive is always negative, and that is equal to negative 4. So our work does check out there. In this problem, number 5, x divided by negative 3 is equal to 5 and 1/3. The only real difference between problem 4 and 5 is the fact that on the right-hand side we have a mixed number, not an integer. So to solve this problem, On the left-hand side, x, the variable, is being divided by a negative 3, so we'll multiply each side by a negative 3. The negative 3's on the left-hand side divide out, they cancel if you will, leaving us with the variable now solved for, x, being equal to, now on this side we have to multiply this mixed number by this integer. We'll change this mixed number into a improper fraction, 5 times 3. We multiply those two, that gives me 15, and then 15 plus 1, that gives 16, that gives me 16 over 3, times a negative 3. A couple ways you could do this. You could multiply and then divide out, or you could cross cancel as it did in the previous example. And in the previous example, I had to cross cancel 7s. In this case, it's a 3 and a negative 3. They're both divisible by a factor of 3. So that would, 3 divided by 3 gives 1. And then negative 3 divided by 3, well, that gives us a negative 1. Then we multiply numerator to numerator, 16 times negative 1. That gives negative 16. And 1 times 1 gives us 1. And negative 16 over 1 is the same as negative 16. So our solution here is x is equal to negative 16. We could check our work by substituting negative 16 into the original equation. So here comes our check. Negative 16 over 3 is equal to, and actually be a negative 3, is equal to a 5 1/3. And in fact, that does check out because our solution, before we multiplied, ended up being 16 over 3. So negative 16 over negative 3. The answer is going to be positive. 3 goes into 16 5 times. The denominator of the fraction is 3, and there's 1 left over because 3 times 5 is 15. That would be 1 left over. So this problem does check out. What I should say is this solution does check out. Number 6, what we have to do is solve the equation x divided by 1.25 is equal to 7. Since the variable is being divided by a number, we're going to multiply each side by that number that is doing the division, or in the denominator, or below the variable. So multiplying each side by 1.25. The 1.25s on the left-hand side, they cancel out. They divide out, leaving us our goal, x, the variable now isolated. On this side, we have to multiply 7 times 1.25, so I can do that work right here. 7 times 5 is 35, carry the 3. 7 times 2 is 14, plus 3 is 17, carry the 1. 7 times 1 is 7, plus 1 is 8, and I'm going to have to move the decimal 2 times, starting at the right, once, twice, to get a final answer of x is equal to 8.75. Once again, we can check our work by substituting 8.75 into the original equation. So 8.75 divided by 1.25 is equal to 7. And we can do that division. 8.75 divided by 1.25 again, with decimals in division, you have to make this a whole number. In essence, by moving that to the right 2 times, that decimal to the right 2 times, I multiply that number by 100. I do the same thing in here. So I'll be dividing 875 by 125, and that actually does go 7 times. 7 times 5 is 35, carry a 3. 7 times 2 is 14, plus 3 is 17, carry the 1. And 7 times 1 is 8. So when we subtract, we get nothing left over. So the left is equal to the right. So the solution, x is equal to 8.75 or 8 3/4, does check out. Be ready for the interactive part of this video lesson coming up next. Solving one-step equations, your turn. As you saw in the previous examples, I used multiplication to solve the equations. what you're going to do is use multiplication to solve these three equations. You should pause the video and time yourself. I'd say about anywhere from 6 to 10 minutes would be a sufficient amount of time. When you're done, continue the video and then you can get the solutions to your work. So pause the video starting now. Welcome back. Hopefully you got all these problems right. Let's take a look at number 4. In number 4, it's x divided by negative 12 is equal to 6. Using the multiplication property of equality, you're going to multiply each side by a negative 12. Now remember, the negative 12s on the left-hand side of the equation, they divide out. They become 1, leaving us with 1x. On the right-hand side, we have to do 6 times negative 12. Positive times a negative is a negative, and 6 times 12 is 72. Now, 6 times 12 is a multiplication fact that you should know, or you should be able to complete that multiplication very easy. It's 2 digit by 1 digit. Problem number 5 is x divided by negative 5 is equal to 4 and 3/10. To solve this problem, we're going to multiply each side by a negative 5. It's because we have x divided by negative 5 on the left-hand side. Now, on the left-hand side, the negative 5s cancel out, leaving us with x. On the right-hand side, to complete this computation, what we have to do is change this 4 and 3/10 into an improper fraction. 10 times 4 is 40, and then we go 40 plus 3 to give us 43. The numerator will remain 10. And on the right-hand side, we're going to express this as negative 5 over 1. We can cross-cancel the negative 5 and the 10. The common factor is 5, so we'll divide both of those by 5. 10 divided by 5 leaves 2, and negative 5 divided by 5 leaves negative 1. So in essence, we have 43 times negative 1 to give negative 43, and 2 times 1 to give 2. We could leave our answer as an improper fraction, or you could change it to a decimal. 2 goes in, well, it'll be negative because it's a negative divided by a positive. 2 goes into 4 twice with no remainder. 2 goes into 3 one time with 1 remainder, so that would give us negative 21 and 1/2. Or, if you wanted to express that as a decimal, negative 21.5. So any one of these three, if you came up with it, would be an acceptable answer. In problem number 6, we have x divided by 2.5 is equal to negative 12.5. To solve this problem, since on the left-hand side we have x divided by 2.5, we'll multiply each side by 2.5. On the left-hand side, the 2.5s, they do cancel out, leaving us with 1x. And on the right-hand side, we have to do the arithmetic. 12.5 times 2.5. A negative times a positive is a negative. And I'll set this multiplication up by putting the 2.5 under the 12.5. I'm going to need to move this down a little bit. 5 times 5 is 25. Write down the 5, carry the 2. 5 times 2 is 10, plus 2 is 12. Write down the 2, carry the 1. And 5 times 1 is 5, plus 1 is 6. Moving on, 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. And 2 times 1 is 2. Add these two together. 5 plus nothing is 5, 2 plus 0 is 2, 6 plus 5 is 11, carry the 1, and 2 plus 1 is 3. So the answer here, 3125. Now we have to put the decimal in. 12.5 has 1 decimal place, and 2.5 has 1 decimal places. So that means our answer is going to have 2 decimal places. So the answer is negative 31.25, or negative 31 1/4, or negative 31 1/2.